Let's see the exercises next. In this first one, we have to determine whether or not each of the operations given below is a binary operation, and we also have to justify our answers. This is the first one where the operation has been defined on Z plus, the set of all positive integers. And for any two positive integers a and b, star has been defined using this equation a star b equals a minus b. The solution star is not a binary operation on Z plus, which you may have already guessed. It's very easy. 1 and 2 are in Z plus, but 1 star 2, which is 1 minus 2, is not in Z plus because it's minus 1. Next, upper 2, this time also we have the set Z plus, but this time the operation is ordinary multiplication of positive integers. And this time it's a legitimate binary operation on Z plus. That is because for any two positive integers a and b, their product, which is our a star b, is a unique element in Z plus. That means it's also a unique positive integer. Next, number 3, here the set is R, the set of real numbers. And a star b this time is ab square. This is also a legitimate binary operation, and the reason is that for any two real numbers a and b, a star b, which is ab squared, is a unique real number. So the solution would be exactly like what we have in part 2. So you mimic that solution and write the solution yourself. Number 4 next. So again we have the set of positive integers, and this time a star b is the absolute value of a minus b. This one is not a binary operation on Z plus. When you first see this, you at once see a minus b. So you sense that something will go wrong because minuses may appear. But then you see that, okay, we have absolute value also, so there won't be any problem, but still there can be problem. For example, if you take 1 in Z plus, then you can consider 1 star 1. There is nothing is telling you that these two elements have to be different, but that is just 0, and 0 is not in Z plus. That is why this is not a binary operation on Z plus. And finally, number 5, where again the set is Z plus, and this time a star b is just a. And this last one is a legitimate binary operation. The argument, of course, is just this. You take any two positive integers a and b and consider a star b, which is just a by definition, but that is a unique element in Z plus. So that is why it's a binary operation on Z plus. So you write this yourself and complete the solution. Let's see another one, number 2. Here also we have to determine if the given operation is a binary operation or not, but additionally, in case it is a binary operation, we have to also see if it's commutative and or associative. And again, we have to justify our answers. Here also we have some parts. This is part 1. The set here is the set of integers this time. Positive, negative, 0, everything is included. And the operation is subtraction. The operation is a legitimate binary operation for any two integers a and b. Their difference a minus b is a unique integer, and that is why it's a binary operation. But it's not commutative, which is also easy to see. 1 star 2 is 1 minus 2, which is minus 1, whereas 2 star 1 is 1. They are not equal. Star is also not associative, since if you calculate 1 star 2, what do you get? 1 star 2 is 1 minus 2, that means minus 1, and 1 star minus 1 is 1 minus minus 1, or 1 plus 1, which is 2. However, 1 star 2 is what? 1 minus 1 is 0, and 0 star 2 is minus 2. 2 and minus 2 are different. That's why it's not associative either. Next, part 2. This time the set is Q, the set of all rational numbers. And the operation is this. A star b is ab plus 1, where of course a and b are rational numbers. And it's a legitimate binary operation, obviously. For any two rational numbers a and b, ab plus 1 is a unique element in Q. a unique rational number. That's why. Moreover, just by looking at this formula for star, you also note almost immediately that it's commutative as well, because ordinary multiplication is involved, which is commutative. That's why. And you can write that like this. For any A and B in Q, A star B is AB plus 1, but AB is BA because ordinary multiplication is commutative. BA plus 1, which is B star A, hence star is commutative. But star is not associative, which you can see from these two calculations. 1 star, 2 star, 0. Oh, and in the frenzy of showing or disproving something in these problems, do not forget that your elements have to come from the set. Are these rational numbers? Yes. They are integers, so also they are rational numbers. Okay. Now let's see this one. 1 star 2 star 0. So we have to calculate 1 star 2 first. What is that by the definition? 1 times 2 plus 1. That means 2 plus 1 or 3. And then we calculate 3 star 0. That means 3 times 0 plus 1, which is 0 plus 1 or 1. Whereas, if we instead calculate 1 star 2 star 0, then we have to first calculate 2 star 0. 2 times 0 plus 1 is 1. So that means this is 1 star 1. And 1 times 1 plus 1 is 2. So you are getting different results. So that means this is not associative. We are lucky to have the two operations, that is addition and multiplication of real numbers, associative, which we use all the time. Had they not been associative, things would have been very messy. We would have had to use brackets, things like this, whenever we say want to add or multiply more than two numbers. And depending on how we would bracket, things would have been different. But luckily, they are associative, so we are saved. Next, part 3. Again, the set of rational numbers on which the operation this time is defined like this. For two rational numbers A and B, A star B is AB divided by 2. The first part, of course, is very easy. For any two rational numbers A and B, AB divided by 2 is a unique rational number. So that means it's a binary operation. And also, for any two rational numbers A and B, because AB is equal to BA, so from this calculation you can clearly see that star is commutative. And for any three rational numbers A, B and C, not necessarily distinct of course, say we consider this combination A star B star C. A star B is AB divided by 2, so that star C is AB divided by 2 times C divided by 2, which we can also write like this, where we do not do anything with this 2, but the numerator is written like this by rearranging things, which we can do of course. In place of this, we have written A times BC divided by 2, which is A star BC over 2, and that is just A star B star C. So you see that this operation is associative and it's also commutative. So it's like ordinary addition and multiplication of real numbers. Next, part 4, where the set is again the set of positive integers, and A star B is 2 to the power AB. Instead of writing a solution, let me give you some hints for the solution. Star is a legitimate binary operation on Z plus, and it is also commutative, but it's not associative. So this part is very easy to write. Why is it not associative? You come up with three elements A, B and C such that those two combinations where you bracket the product A star B star C in two different ways, they are not equal. So you try to think of such an example. Next, part 5, again we have the set of positive integers, but this time star is defined like this. A star B is A to the power B. And these are some hints. This time also star is a binary operation on Z plus. You write the reason why. And this time star is not commutative. because 1 star 2 and 2 star 1 are not the same. You do the calculation yourself using this definition of star, and also it's not associative again because of one such example. 2 star 1 star 2 is one thing, whereas 2 star 1 star 2 is another thing. And finally part 6, where this time the set is the set of real numbers from which -1 has been removed. You will see why, because the definition of star is like this. For two real numbers a and b, a star b is a divided by b plus 1. So we don't want b to be -1. That is why -1 has been removed. And again the same hints. Star is a binary operation on this set. And star is not commutative again because 1 star 2 this time is also not equal to 2 star 1. And it's also not associative because if you consider the product 1 star 2 star 3 bracketed in the two possible ways, then they are not the same. You can do the calculation yourself.